Hello. Can you hear me? Testing, testing. This is for the live feed, sorry. This is not for the audience here. This is more for the audience on the stream. But hello to you too. This is a test. Great. Oh, successful. Wonderful. Okay, great. How many are we? I think it's a good quorum to start with. All right, folks. Hi, welcome and good evening, or ein wunderschönen guten Abend. And yeah, I'll not test my German too far now. It's geht. Okay, so if you do want to have some conversations here and there, we can absolutely do that. I do want to start off with saying that this is the first Kubernetes and Cloud Native Berlin meetup for this year. If you've noticed in the CNCF Berlin chapter, we now also have the hotel meetups happening regularly. And I also kind of do want to try and promote that because that's a topic that's of interest to probably a lot of you. It's on similar lines, if it's not the same. And while Kubernetes in itself is a big, broad project, Cloud Native is a big, big ecosystem, it's nice to have some of these meetups kind of thrive and they come up on their own, which focus on specific topics. So if any of you are interested in open telemetry and observability, do choose to check those events out. Those meetups are also probably being planned bi-monthly or so. And I also want to start off with the first meetup of this year for the Kubernetes and Cloud Native Berlin group by giving kudos to Bertram. Thank you so much for helping us organize this. I know it seems very seamless, but like I always say, the more seamless it seems, the more work there is and quiet work there is behind it. So big thank you to him. Big thank you to the Cast AI folks for organizing our pizzas and getting that sorted. It seems like another small little detail, but it's what helps kind of run our meetups as smoothly as they do. And for anyone else who's interested, please try and pick up the initiative and try and see if you can volunteer along. The idea is to try and stay as transparent with the community about this and not have just one or the other company, but also to try and involve a broad spectrum of companies within the city to participate. So if anyone's interested, please pick up the mantle, reach out to us, and help drive the next meetups to come. There's a simple code of conduct. I don't want to stress too much over it, but we all need to be respectful. And if you disagree with opinions and views here and there, keep that respectful too. I think it's important to have some civility in that sense. I don't want to emphasize too much on it, but sometimes heated arguments can, be something that you don't want to ruin an atmosphere over. So yeah, let's engage in healthy debate. Absolutely welcome. But yeah, let's kind of keep that civil and be inclusive of all kinds of views. And more importantly, this meetup is a pre-KubeCon special. So I don't know how many of you are planning to be at KubeCon London. Hands, everybody, a show of hands. Oh, great. Okay, so some of you may find this more topical than the others. But for those who cannot go but want to follow up on what happens at KubeCon or are planning to go at some point or the other, and you want to understand what it's like or prep for it, some of these talks will give you an insight into what actually goes on at KubeCon, like some of the projects that people are working on, the involvement with CNCF, which is obviously a very huge organization, and we all work towards kind of making sure that a lot of these open source projects and everything that are within the CNCF's mantle also kind of run smoothly in our own capacities. So without further ado, I will hand over to Bertram, who will start off the evening. And there's a lot of conversation that's going to happen around Kubernetes for the first two talks. We break for pizzas and networking. And we come back around 7:45, if I'm not mistaken, according to the program, which we may extend up to 8, but we will check in with you. And then Dotan gives his talk on the open source project. So a big round of applause to our speakers for today. Some of them have also made it, Some of them have also made it from different places. So yes, we let them talk about it also and their journeys and everything, and also attending FOSS Backstage. So, and the experience of it all. If some of you are curious, FOSS Backstage happened today, and I think it's on tomorrow? Yesterday and today. Okay, so you can ask Dotan more about it, and also there are many folks here whom you can discuss this with. So have a good time. Have a lovely time to engage with these folks and everything, and of course the pizzas and the beers. All right, let's kick it off. Thank you.
Yeah, so welcome also from my side. Maybe just two more points regarding the office. Yeah, feel free to grab beers. As you also notice, there's a lot of beers, so nobody's coming to the office anymore, so they need to be taken care of, let's say. And yeah, toilets are down the hall. You probably will find them. And if there's anything else, just ask me or Benazir. She also knows the office, even though it's not hers. Yes, so, and then from my side, I'm Bertram. Here's there's another name on the slides because it's basically the same slides that we will also present on KubeCon. Skander unfortunately can't be with us, but he'll be in London next month. So yeah, if you see this now, you probably don't need to see it in London anymore. Exactly. So I'm working for the Mercedes-Benz I/O. The Mercedes-Benz I/O is basically kind of a IT hub for the whole e-commerce topics surrounding Mercedes-Benz. Also other topics and also after sales and everything what is connected there, but basically that. And I'm part of the platform team of Mercedes-Benz I/O. And we are providing Kubernetes clusters mainly to in-house product teams, classical, let's say, platform approach. We are currently having 120 clusters. It's always like a bit dynamic how many we are there actually because of onboardings and offboardings of our product teams. The solution is meant to be also scale a bit higher than that, but this is what I basically like just to set the scene, because we are always having the platform approach in mind when scaling those clusters in a very, like, let's say, diverse setup with like different use cases from the different teams. So then let's start. What were our challenges? Where did we start? Of course, the whole big topic is like the costs, driving costs down. I mean, that's why it's basically the biggest part of being more efficient and using the clusters more efficiently. And what had we in the beginning? So we as a platform, we provide our clusters as a service, but teams sometimes don't even have much to do with Kubernetes in general and what they actually need to do, what are the best practices even, or how to do things there. So like a big issue of teams, and still is like the right sizing of workload. So people don't know what to set for the requests and limits, and then due to that over provision or even under provision, which now also happens more likely when you scale more dynamically, let's say. Then also from a platform perspective, the usage of old no instance types, we had basically a static node type used across all clusters, which is also then ending up in pictures like here, right? So you have some use cases, some workloads which don't fit within the node type you define, and then you get a call, you get a request, you need to change that for a single team. Or like it's very inefficient to use, right? So if you have like big nodes but like a small application running, then it's also not nicely shaped in that way. And the big question, that's why I also started on the platform topic, is like doing the whole thing at scale and basically for other teams. So we have no idea what workload is running there. We don't know the use case. We don't know how many applications they are running. If it's like, I don't know, 100 thousands or whatever, or maybe even like 2 or 3. This is also sometimes the case. So basically in this kind of diverse setup, we are trying to have the one platform to provide the best service. And those were our challenges. Of course, the big topic here is like the costs. Now more than ever probably, as most of you feel probably or share the same pain. And then also, because now I share some slides of the tool we are using. It's CastAI, it's no secret. I honestly think like if you have like a probably small team or a team which knows what it's doing, you probably can achieve a lot of stuff of that also without CastAI or with other awesome tools. So that's what I'm trying to say is I don't want to pitch you any tool. And I think we will also talk about things which are out there in the ecosystem and architectural approaches you can use. So don't take it as a pitch. Just saying that before. But how do we address those challenges? So for CastAI, the biggest thing is of course like the bin packing part. For everybody's aware what bin packing is like referring to in this round. Otherwise, no. So bin packing actually means like maybe let's go back. If you have a picture like this, you see like a lot of small pods running on like maybe bigger nodes. And bin packing means that you can pack those pods, those workload together to scale down the nodes, and then in the end, of course, saving cost by doing that. And like this is the biggest thing to actually lower cost, I would say, at least in terms of efficiency. So there are two things which are basically done. So there's currently checked for basically underutilized pods and in the cluster itself, and then it's getting checked if there are bigger nodes which still have the capacity to run those pods, and then scale down the node. So with cluster it's called a Victor, but there are, for example, ecosystem tools like the descheduler or things like that, which you can also use to make use of the same principle to deschedule and bin pack nodes or evict workloads. And then there's another thing provided by Caster Ice. So there's like, it's called a rebalance mechanism. So based on everything on the request you are setting, and now we are at the right sizing of workloads again, the problem. So based on the request you are setting, your cluster setup is calculated, and this is basically what we are seeing here. So it calculates what nodes are actually needed for the workload you run, and it sets up the nodes which are needed only for your workload. That's like a second part the tools provide, and like a second strategy basically you can follow to every once in a while check your cluster state for over-provisioned nodes. Then, I basically talked about that part also quite some time. The workload right sizing, so it's hard to set proper requests and limits, especially requests. And here, for example, in the open source, or like what Kubernetes as an auto-scaling mechanism brings is like the VPA, the vertical pod autoscaler. So it also sets requests out of the box. There's also a component provided by CastAI, which we are using for that. So the idea here is to dynamically set requests and not to monitor and dev and then setting it every time on your own. But probably Kim will also talk more about that in his part. Yeah, we didn't really align very well, but I think he can like then.
I can skip some parts.
Yeah, exactly. So this is a whole part of workload right sizing. So you always have the gap if you oversize your workload, especially when you calculate your setup based on the request, and you can also over-provision your whole setup in the end. Or what also happens here, and what we see sometimes when teams don't do workload right sizing at all, or like sizing in that sense at all, not even right, then the cluster can be too small, because in the calculation of the setup, if you have set too less, then the workload does not find room on your cluster to being deployed to. So this is also something that happens when you scale more dynamically your whole setup. And then one thing which is not maybe you noticed in the challenges in the beginning, but what came along with using the tool was really, let's say, convenient switching to spot instances in non-pod environments. And everybody knows what spot instances are, or need a quick refresh, but everybody basically, yeah.
Very quick question. What hyperscaler are you talking about?
Sorry?
Which hyperscaler are you talking about?
Hyperscaler?
Yes, like Azure, AWS,
AWS. It's AWS. Sorry, yeah. It's a good question because the first picture was not AWS, but yeah, we are talking AWS.
And Spot instance is Carpenter provisioning, I guess.
It's what?
It was Carpenter provision the Spot instance, I guess.
No, we're also doing it via the Castro autoscaler, but it's basically a, I would say, Carpenter-like experience. Yeah, I'm kidding.
Oh, sorry.
No, no, exactly. But it's the same principle.
Okay.
So yeah. But we also I wanted to say, so as a platform, like we need to like get things quickly out of to the product teams. That's why we teamed up with like a good solution out there, at least in our opinion. But as also said in the beginning, you can probably achieve a lot of the things I'm just talking about also by using tools which are in the ecosystem out there. If you know what you are doing.
We'll have a shit later.
Yeah. Yeah, and then yeah, Spot came to our radar, of course, because in the first place we just had like the efficiency. Wanted to target that part, and then Spot came along and we just said, yeah, why not? And yeah, it's also just an example on like a test we did basically on lowering the cost in comparison to on-demand instances on AWS. That's actually my last slide already. Because back to the challenges again, changing from static node instances, having always scaled the same, comes with a lot of caveats, let's say, especially in our ecosystem of the company, because a lot of our workloads is Java-based. And probably you all know what that means. So you have like a big discrepancy between resource consumption at startup and resource consumption in runtime. So in addressing that by setting, for example, requests and limits properly is kind of hard, because what is actually needed? Is it needed like, I don't know, the 4 cores in the beginning, or is it just the 20 millicores during runtime? Because in the end, the startup is needed for the application. So it's really hard to efficiently scale Java workloads, and it's a big challenge we have. Then another thing, and this is more like from a platform point of view, as both points are kind of like facing in the same direction, is the adoption of our features. So as a platform, you can put out whatever you want. If product teams are not picking up the stuff you're doing, we are struggling a lot of that. Even though we have tools in place, like for example, Kyverno, trying to foster best practices and so on. But yeah, it's still hard to teach people to do the right things, even next to their product work. I mean, because in the end they have another focus, right, and not like making it most efficiently. That's why it's sometimes hard to ask. And then also like the whole resiliency part when it comes to scaling dynamically. So now it's more on the team side to, for example, define pod disruption budgets for outages, or like not even for outages, for regular cluster operations, like maintenance. Everybody familiar with what pod disruption budgets are? And why they are important? And the same goes with the topology spread constraints. So to assure high availability and spread across availability zones, or even like nodes itself, and people sometimes doesn't even hear about it. So you need to teach those principles a lot to people to make your cluster more resilient. And there's also like a challenge coming from like everything was basically over provisioned in the beginning, everything was static, everything kind of worked, and now you put a lot of new things on the product teams for them to adopt. That's a challenge for us as a platform. And yeah, having said that, I think this is already my 5 slides. Yeah, it will be the same on KubeCon. So I spared you the talk there, and I think Kim will take the opportunity to maybe go in more details on some of the principles. That's why I'm not sure if anybody gets questions specifically for my talk now, because otherwise, if you want to talk about architectural things or principles, maybe it's better after Kim, but sure.
I would have one question. So,
Yes.
First of all, great talk. I'm just curious because you said that like one of your biggest challenges is to scale down and also like moving pods. And the thing is, what I mainly saw like when scaling down is, and this is my question, like how many pods of you where you have are stateful? Because the main challenge that I figured on AWS is like if you want to consolidate pods on nodes, and then you have like a spread, as you described, then like scaling down with stateful workloads, it's like pain in the ass on the AWS, and then we have stateless workloads with small pods, and it usually works pretty fine. So if you say like you have that big problems on scaling down, like how is the highest percentage of stateful workloads, and how high is the utilization of operators on those stateful workloads in your deployed resources?
I'm not too sure of, how to comment. No, because it's also like super, that's what I meant, like it's like a super diverse setup in terms of we providing the whole thing, and then they are responsible for the application. So that's why it's also this kind of division in monitoring and having insights in how actually things are running.
Maybe that's a good trick. That's what I always do like on Grafana dashboards. It's like when you monitor, like just like monitor stateful and stateless separately, and then you can see the differences there.
Yeah.
And then play around with the spread for stateful workloads, and then it's usually.
We have usually no stateful set. I mean, there's like some specific product teams which are special as always, as you always have those, and they need a little bit more care. But usually, people are happy with like having deployments and having them shifted around. So this is for the majority, I would say, stateful set is not an issue. It's also not part of our what we provide as a platform.
Well, no, the stateful side is not the issue. The thing is just if you have stateful workloads.
Yeah.
Because the problem is if you have like 3 availability zones.
Yeah.
You cannot move EBS volumes
Yeah.
from one AZ to the other. So either you go to like EFS, which is like we don't want to do because
Yeah.
we don't have to write IOPS. But if you do, then you will need to replicate. So they're like good way to replicate the EBS volumes between the regions.
Yeah.
Which is also quite recent and a bit unsafe.
Okay, now I got. Most of the teams also don't use like volumes in that sense as well. So they have everything in databases stored, and then they just consume like the RDS endpoint or whatever database they're using in the end.
Following best practice, keep the state out of the cloud.
Exactly.
We all know that it's unrealistic.
Well, I mean, like if you don't follow best practice of hyperscalers, yeah. If you follow best practice of cloud native formation. So that's like
different.
choose the side you want to be on.
But yeah, then no, but it's good, and we can probably continue afterwards for sure. Just because it's kind of goes into the same direction next talk, so we can more talk principles also there. And the issue is because I love to talk about the challenges, and also maybe someone of you got a good idea to face those actually, because we are sometimes out of ideas, even when product teams can reach out and ask us how to do that, and yeah, I don't know. Let's try this.
There you go. Einfach.
Genau.
Okay. Ja, danke dir. So. Ja.
Okay, looks better. Okay, perfect. Then, thank you all. My name is Kim. I'm the field CTO of Cast AI. The funny part is I'm not giving you a product pitch. Bertram already did this. So I don't want to speak about what our product is doing. If you're interested on this, we can think about this later. I would like to handle this topic in a more general and architectural way and discuss just the challenges and see what the Kubernetes ecosystem gives us for this. So doing optimization for Kubernetes in general. So first of all, Kubernetes is easy. We all agree to this, or it's a very lightweight architecture. The challenge is coming with all the things Kubernetes is not handling, because Kubernetes at the end is a container orchestrator. And all the other tools we need for successful operations are part of the CNCS ecosystem. Oh, it's a very good graphic. But we see it's a very complex and growing ecosystem. How can we deal with these? How can we handle the zoo? The answer should always be automation. I know there are a lot of people still outside. They are doing fancy bash scripts and using CLI Ninja skills to automate and administrate things. But our goal should be do this in an automated way. We want to have these unicorns and rainbows instead of fancy scripts somebody is doing to protect his own castle. Also things I did a lot of years for consultancy, and it's getting better, but there are still people out there thinking automation kills my job, where I always say that's never true. It makes your job interesting because it gives you time for the interesting part and not just firefighting. So we can go, I'm pretty sure you all are aware of this. Who's not using automation today? Okay, if there's somebody who will never say yes today. So at the end, we want to have automation in place for the complete journey. We want to automate the creation of cluster. We want to orchestrate the to automate the life cycle of the cluster, the tooling, the application, all these stuff should be in Git and rolled out by some tooling. So looking for Kubernetes, what do we need to take care of, and what do we need to automate and to handle to be an efficient cluster? We already heard that there are some challenges in regards of nodes, in regards of node sizing. What is important about this? At the end, the worker nodes is where you spend some money. And if the worker nodes doesn't fit to what your application needs, you end up with a fragmented cluster. You have a lot of nodes there. Kubernetes is not really efficient in the scheduling. If Kubernetes has the possibility to schedule pods, Kubernetes doing some wait, what makes sense, where is enough resource available, and then Kubernetes place the pods, and it will look like this. You have a lot of nodes, they are all horrible utilized, and you're paying a lot of money, and Jeff Bezos has enough money to spend it for a new boat or whatever. So we want to cut these costs. We want to have a more optimal cluster. And at the end, for sure, it's the same for all the platforms. Is it AWS, Azure, Google, Alibaba, vanilla, on-prem, whatever you're using? By the way, from this audience, is it mostly public cloud what you're using? Do you operate things on-prem? Do you have VMware stack still running? Is it public cloud? Yes? Okay, AWS? Okay, Azure, guys? Okay, Google? What else? Alibaba? Oh! Stack it. Okay, Stack it. It's Schwarz IT. Nice. Okay, perfect. So at the end, the challenge is in each of these clouds. So what can we do? What does the Kubernetes ecosystem gives us for this? The answer will, okay, this is autoscaling, sorry, in general. What do we want to do? We want to do pod placement. We want to do bin packing at the end. Cast AI called this Evictor, we already learned. We have bin packing. So we need a system which is looking inside of the cluster and check what makes sense. If there is a possibility to reschedule a pod from one node to another. What means reschedule? We kill the pod and start it somewhere else. That's also the question how to deal with stateful applications with this. And on the other side, how to deal with single pods. Single pods are problematic in this case because single pod means, yeah, at the end, the service is back one. Single pod, if we kill this pod, it takes time until it starts. During this time, service is down. Challenging for Spot, by the way. So, long story short, what do we want? Without good autoscaling and bin packing, your cluster looks like this. You're paying a lot of money, but you just need this amount of resources. This is what we want to save, we want to optimize by using automation inside of our cluster to do automated infrastructure provisioning and bin packing to keep the cluster as small as possible. Another challenge for public cloud is, what is the right instance for my application? Who is able to have a clear picture about the roughly 600 instance types which AWS supports in Frankfurt? Nobody. Nobody has an idea what is available. So what are the people doing? We know our common families, the 5 or 6, and you will just use them. You just pin them to your cluster and just use them. And maybe there are some better instance types available. Maybe there are some cheaper instance types available, but you are not aware of this if you're doing the static instance types pinning. So we want to have a system which is able to look what is available in this region, look what fits to our needs in regards of resource requests, in regards of pricing, and then bring these instances in at the right time of your where we need them. We already highlighted this, the difference between on-demand and spot. You said you're all aware of this, so I don't need to speak about this. Spot, at the end, we want to save money. We want to use the spot capacity of the hyperscaler.
This is number on that spot is 10% of on-demand instance.
Yeah, it's
like according like official AWS information and also like experiences, like you're like usually get between 25 and 30%. So
yeah.
I'm not sure you get this 10% spot instance, but if you have like
Yep.
about reselling, right?
Yep. That's true. So at the end, and also there, at the end, we want to have the spot price. If this 10% are valid, I don't think anymore, but it's 30. And at the end, it's changing. But we want to have a solution in place which is doing this for us. So say we want a spot. We said, you all said you know what is spot, so we don't need to talk about this anymore. At the end, it's just about spot instances are cheap, but they can be taken away to any time. So we need to think about how our workload is able to tolerate this, because in this high availability should come from the workload. Each node can be done at each time. Already said, spot prices changing a lot. Spot prices can change over the runtime, so also there we should be aware of this. But these are basics. You're good with spot. So let's focus for a short moment on workload. Bertram also, where's Bertram? There. Talked about VPA, pod right sizing, what does it mean, and why do we need this? Kubernetes, at the end, the scheduling is based on requests. All infrastructure autoscaler looking for the requests. So that means if the application requests 6 CPUs, the infrastructure autoscaler will create a machine which gives us these 6 CPUs. If the application uses just a half CPU, we are still provisioning these 6 CPUs. And we are blocking these resources for this workload. So that means we also need to make sure that our workload is also optimized. Not only focusing on infrastructure, this is mostly low-hanging fruit, but then next level should be looking in the workload level and also have dynamic scaling based on real usage for our applications. So Kubernetes gives us 2 options, horizontal pod autoscaler and vertical pod autoscaler. Horizontal pod autoscaler, it's just changing the number of replicas we have. Checking, okay, we are running at 3 replicas, a storm is coming, a lot of traffic is coming. We scale out to 10, and then we scale down if the storm is over. Vertical pod autoscaler, we have to change the request. So we see, okay, the pod is requesting, I don't know, 2 GB of memory, but the usage is much more. So we should increase the resource for this memory to make sure we are not running into an out-of-memory kill. That's what the vertical pod autoscaler is doing. If we want to combine all of this together, we start with a fragmented cluster. We have these 3 nodes, and then using VPA and HPA to combine these workloads, optimizing the pods, and using a bin packing solution to push them together to keep the cluster as small as possible. Yeah, for sure, respect some topology spreads and anti-affinities. But this is the way how it's working. This is what we want. This is some data from our researchers, of our cloud benchmarks. We see 10% of the CPUs which are provisioned in the cloud are really in use. 90% are just idling. They are not in use. They are not requested. We just have it there. Last year, it was 13%. So that's the result of the analytics of 4,000 clusters. Yeah. But I'm here, so that's fine. But who is interested on this? The full report is available on the Cast AI website. Just download it. Could be interesting. So at the end, we have infrastructure right sizing, we have bin packing, we have vertical and horizontal pod autoscaling. Everything is awesome. Or is it more like what we already realized? We are shifting problems into Kubernetes. Because at the end, the problem is legacy applications, stateful workloads, machine learning stuffs, workloads which cannot be interrupted. Some Java monoliths, we are shifting into the cloud. They are running there. It takes decades until they start. We cannot touch them. Single pods, not able to replicate. What can we do with them? So they are the blockers. They are the most challenged. Everything which is stateless, easy, started, have multiple replicas, fancy stuff. But how can we handle the state inside of this? So, and this is where container live migration comes in. We want to have a possibility to migrate workloads from one node to another node without restarting the pod. Like what we know from virtual machines. VMware was doing this with vMotion. I don't know how many years ago. There was the first player which was able to move data or move virtual machines from one node to the other. This is what we want to do with pods, giving you the ability to handle problematic workloads inside of your Kubernetes and migrate them from one node to another. Do you want to see this? Should we try it? It's a alpha feature. Let's give it a try. Also, between AZs depends on the storage.
Yeah, I mean, like if you have like managed like between AZs without restarting, then no.
So let's do this a little bit larger. Take this one. Oh, come on, come back. So.
Before we see the demo, can you explain a little bit, like if this like make you lose any request or anything? Because I've tried this before in some hypervisor. It was really nice.
Mm-hmm.
For example, if you are logged into an instance with SSH, you don't even feel it. Maybe you feel a hiccup if you are like tailing some file. But if there is request, usually you don't lose them, or maybe lose it for less than a second. So here, what's going on? Is it really similar?
This is exactly, this should be the behavior we want to see, that there's no big delta in between.
Are we seeing it was like stateful or stateless? For stateless, it doesn't really make sense.
For stateless, it doesn't care, because we don't need to, exactly, for stateful. We need something, where's the state in? For sure. So let's see. Sure?
Can you zoom in quite a bit?
Yeah, sure. I need to organize my windows a little bit, because I need 3 of them. So here at the end, we just need, no, that's the wrong. So, I have some pods. I have 2 pods. I have an Nginx, which is just my reverse proxy, but the interesting one is I have these, who can remember on a game which is called ToxRacer? Okay. So it's a desktop game. It was shipped with all these Linux desktop stuff, and this was ported to Kubernetes. Was an interesting journey. And we see that it's just one pod running. It's on the machine, ends on the 215.
Could you describe the pod?
Sorry?
Just describe.
Sure. American. What do you want to see?
The PVC.
There's no PVC behind.
Oh, as you said, it's but stateful.
Yeah, it's the same working. I just want to showcase something. But we can do this with a PVC behind this as well.
Please, because as you said, otherwise it makes no sense.
Yeah, sure. But it's also keeping about the memory.
Memory.
Yeah.
Yeah,
It's an.
but why would you keep the memory? It's not stateful because you can just have a scale anyways.
But because I have in-memory database. Java. It's just an example. But yeah. Yeah. So the exactly. So let's see. Just in regards of the time, a little bit. Give me my. So let's see. We have. So I have a service which is running this game. And then, where is my different? Oh, come on. And, there it is. Okay, we have this guy, we have that guy. Here we go. That's a bit tiny. So, wait a moment. Need to get my. I have too much stuff open. Here we go. Need my port forwarding for my live controller, and then we can start this. And then, what I say? Let's. Okay. So we have the watch. We see that this pod is running in these 215. In this 215 node. I have 3 other nodes available, 208 for example, and I want to migrate this job during this game run. Let's see if it's working. Yeah, so game is started. Want to migrate them to a different node. 208. Let's do this. Migrate. We have a short. We see the game is still running and the machine switched over to a different node. It's a pretty new feature we developed. We're spending a lot of effort to get this GA. Should be in the second half of the year. We will pitch this in a larger scale at KubeCon. For the moment, it's running in AWS. It will be ported to Azure and Google as well. And then, if this is done, also focus on some on-prem stuff. Because we see there's a need in Kubernetes. Kubernetes works fine for all these applications which are designed for Kubernetes, which run in these 12-factor apps. We are stateless, state is stored somewhere else. This is all fine. But at the end, the reality, and this is what we see every day, is 90% of the applications are exactly like this. And then we have 10% of the applications. There's this Java monolith which is ported. That's a problem all the time during updates. If we have to kill this pod, it takes 10 minutes to get up and running. So we can only kill these pods or move these pods in the night during maintenance windows. And a solution like this gives you the possibility to move this application without restarting it. Next time I will give you. For sure. There's one, yeah.
So you basically have to have an idle node always around, so that you can.
No, it's also working for.
So if there's a new node coming up, so roughly maybe a minute or 2 minutes.
Yeah. So it's also, we are including this also in our bin packing mechanism to have the bin packing there. Looking, we need to get rid of these pod. Looking, do we have the possibility to schedule it somewhere in the cluster? If not, we will trigger a new pod, a new node, waiting until it's ready, and then start the migration process. You.
Work with GPU application as well?
GPU? Yes. Not yet. GPU is tricky, but yeah, it's part of the roadmap. But for now, it's not inside of the scope. Yeah. Yes.
Do you need a special kernel for that?
No.
On LVS?
No.
Or is it all the support on
It's supported in the standard one.
And you cannot only port application with memory pressure.
Yeah.
Memory buses.
Yeah. Sure. This is. There are limitations. It's also the same for VMware vMotion is not working with SAP HANA because we have technical issues. It's also there the same with if the network bandwidth is not enough to mirror, I don't know, 128 gigabyte of memory, which is heavily changing. But these are technical limitations.
But it's a technical limitation that
Yeah,
in the AI space.
exactly.
No.
Yeah, I think you?
So I think a couple years back, container-like migration was all based on CRIU. So is this
Yeah.
work-based?
Yes.
One other question, just from the perspective of legacy applications, would people take the time to move them to containers, or would they just stick with VMs and use, I don't know, use whatever? I mean, if you want to run VMs on Kubernetes as possible nowadays, and just light migrate those VMs, what's your customer demand? Is actually the question.
So what is our why we are doing this, or what is it? Yeah, okay, because we see.
Like most people running legacy work,
Yeah.
they'll just stick with VMs.
Yeah. So, so what we see is that what I said already, in all of these clusters, mostly there is a tiny piece of these applications which are not a good fit for Kubernetes. And for these, exactly, this is the use case. Having batch jobs which cannot be terminated, also in combination with Spot. If depends on how heavy the memory is under pressure. If you have applications running in Spot, which are not really a good idea for Spot friendly, like batch jobs and stuff like this, if it's possible to migrate the memory in these 2 minutes of the Spot termination, you can use Spot for workloads which are not really Spot friendly. Sure.
I wanted to ask, how do you get access to, you said AWS, but is it marketplace, or how do you get availability to this feature?
To this feature, you have to be a Cast AI customer. Yeah, so this is something what is part of the Cast AI suite. But it was, yeah.
On the corner of your screen, you showed us a UI where you chose which node.
Yeah.
So my first question, what is this UI?
Sorry, yeah.
Second question, I assume it's not only about manually moving things around.
No.
So it's not part of Cast AI to move things around before shutting down a node? Is this
Yes.
part of the feature now, or is it the future?
That's coming if the feature is G8. At the moment, it's alpha state, so that's why it's not part there yet. And also, this is just for debugging and for triggering events there. At the end, what the UI is doing, it's creating an migration custom resource definition object, and then the controller will pick it up. This UI is just for us internally for debugging things like this. You will never touch these in the real life if it's part of the product, because then it can be controlled for sure. If you want to trigger a migration of an application, you will just create this object for this. But the journey should be that the auto-scaling and the bin packing components will shifting them in the backend. You don't need to. You will not know, you will not feel it, you will not touch it anymore.
And in Cast UI, do you do like migration for any pod, or for pods where I specify some label, or how do you control this? Or is it for all pods of a stateful state?
It's configurable. You can allow them to do everything. You can add Kubernetes labels to this to do filtering, which components you want to allow, which you don't want to allow.
Yeah, but I'll still be curious, like, if we talk about this, can Cast AI, like, if we go back to the example.
Yeah.
I don't know here, but the EBS volumes, like,
Yeah.
also the shift like from one AZ to another one, because this is like the major problem that you're having when scaling. Because this was involved like EBS snapshot
Yeah.
copy and
You need to implement. This will require an implementation for the snapshotting of the storage or the copy process of the storage. The question is there a need for to do this?
there's like a massive need, because if you have if you don't have like a 3-tier replication,
Yeah.
or something like, if I have like then one FZ goes down, it's fine. But if I, for example, have like a non-replicated Postgres database,
Yeah, okay.
then I need to like shift it from one to another. Then
Yeah.
like Kubernetes open source that can do that.
Yeah.
However, this is like really complex to do, so that when we work with clients, it's
Yeah.
a bit challenging.
Yeah.
So if you like, do like an automated solution that solves this problem, and now one IZ goes down,
Yeah.
the question is, can it solve
Yeah.
this problem?
Yeah, agree. Okay, I can't answer this right now if it's part of the roadmap.
So maybe that's a feature idea, because if that's gonna work, then I can
Yeah, okay.
do business.
Well, I will note it down and sync with the product team. Sure. Anything else from your crowd? Okay, then thank you for your time.
thing like the pizzas are coming shortly. Please would be cool if you find data privacy, smoky, screen and so on. So it would be cool if anybody.
I was thinking, I like the feature.
Yeah.
I was thinking right now we see it's in a state where there is a controller which decides now I want to move this pod from a machine to another.
Yes.
Or someone manually do it. However, I was thinking of some example I did with virtual machines in the past, and I want to ask you if this could be a future. And what I tried, I had two machines. At that time, I was using Hyper-V from Microsoft.
Yeah.
And I had two machines for this. The virtual machine was created running here. I did some configuration to make sure it can automatically migrate, and I pulled. I pulled the ball.
Otherwise, it doesn't capture your audio.
Okay.
Yeah.
Okay.
It's very devices. Just be careful, there's a charging cable and cords and everything. So, yeah.
I have cords as well. Let's go around this one. Is that? Yeah? Very good. Okay. Whew. Are we good to go?
Applause for Dotan, everybody.
Hey. You want to join us here? Just lots of room. Whoever wants to join us, still room over here. Great to be here. And before we start, I'd love to have a photo with all of you. Is that okay with everyone? Yep. I'm taking it back to my, I'm a CNCF ambassador, and seeing the local cloud native community is very exciting for me personally. So if I can have a photo with you, it'd be great. Folks, if you want to join us, we're starting now there. So let's have this one. Okay, here we go. And everyone say cloud native. Woo! Brilliant. So thank you very much. Really, really excited to be here and to meet the local community. And today I'm going to talk to you about OpenSearch, the open source path to search and observability. But before we start, I just want to get to know the folks here. So with a show of hands, how many have heard of OpenSearch project? That's amazing. How many, don't leave the hands, how many use OpenSearch project? That's brilliant. And how many know Elasticsearch, Elk Stack? Okay, very good. So we have a familiar audience. That's amazing. So let's a word about myself. So my name is Dotan Horvitz, and this tweet, this picture is actually from last year here in Berlin, where we held the OpenSearch conference in Europe, the first one in Europe, first edition. So it was really exciting to be on stage as part of the community, and I hope that some of you at least were able to join when it was hosted in your hometown. I'll tell you more about OpenSearchCon later in the slides, but definitely highly recommended. You may say that I'm an evangelist for the OpenSearch open source project, and in general I'm a developer advocate at the AWS open source team. Yes, there is such a thing. We're dedicated solely to open source activities, and I myself am focused on OpenSearch and more broadly the open source observability project and ecosystem. So, you know, OpenTelemetry, Jaeger, Prometheus. If you have any questions or things like that, happy to discuss these as well. Outside my day job at AWS, I'm also a CNCF ambassador. So as I said, really exciting to be here. And if you have questions about the CNCF, I had interesting chats here about the KCDs, Kubernetes Community Days, and others. So or the stack or anything else. You saw the scary landscape that was shown before. Happy to answer any questions about that. And I also run the Open Observability Talks podcast. I even found one follower here on here, so you can ask him for recommendations. But if you're into open source, DevOps, observability, these topics, just check it out on YouTube or wherever you get your podcasts. And as you can see, you can find me everywhere at Horvitz. My surname is my handle everywhere. It tells about my age, I guess. But these days, mostly about LinkedIn and Blue Sky, but also on Mastodon, Twitter. I have a YouTube channel. I have my blog on Medium. So feel free to reach out after if you're shy of asking here. And let's talk about OpenSearch. And I want to start with a bit of the history for those who are less familiar. So OpenSearch started 4 years ago, back in early 2021, as a fork of Elasticsearch and Kibana, after these projects were relicensed off of open source. So they used to be Apache 2.0, and then they moved into a non-open source license, SSPL. And for obvious reasons, the community wanted to keep the projects open. They wanted the open source alternative for search, for observability. And credits to AWS. Back then I wasn't an AWS employee, but still saluting to the company for stepping up and taking on the very non-trivial work of forking, and we actually have people here that were involved hands-on with doing the fork. You can ask them, non-trivial whatsoever. So that's how it started. So it's actually the very last version of Elasticsearch and Command that were Apache 2.0 licensed back in the 7.10 or 7.10.2 to get the latest patches, and that was the origin of the fork. That was 4 years ago, and I'm glad to say that the project has come a long way in these past 4 years with 23 new releases of the project since then, over almost 130 different GitHub repos. We can see here that really the community has a lot of support and a lot of enthusiasm around it. And I guess what you can see in the numbers, I like it showing like 90 different companies that use OpenSearch, develop solutions over OpenSearch, professional services or whatnot that partnered with the project. I think it's nice to see. We can see 3,600 members on the public Slack. We can see 6,800 over in the forums. So over 1,000 contributors from, I think, over 30 organizations. So really nice to see the involvement in the community. And today, 4 years after the fork, today it's now the 4th ranked search engine on DB Engines. I actually pulled it from just last week, I think, when I prepared the slide deck. So it's pretty up to date, and it's pretty impressive to see on the search category. And actually, I love the fact that it's also green on these. I don't know, Chris, if you saw that, but like seeing the trending February and March trending upward. So good vital signs that this thing is actually being used. And really the most exciting major update on the project is that back in September in Vienna during Open Source Summit, we announced that the OpenSearch project is moving to the Linux Foundation. So it started as a fork that AWS led, but now it's a foundational open source. In fact, there is a sub-foundation, the OpenSearch Software Foundation, a non-profit under the Linux Foundation that is tasked with having it fostering the open governance, open collaboration. That's the mission statement of this organization. So now it's independent, it's vendor neutral, so it's open grounds for others to take part. It has its own governing board, it has its own technical steering committee. Here are some logos from the governing board, other companies that are involved. You know, we're here in Germany, so everyone knows SAP, obviously, but other big names, Uber and others. These are the companies. Obviously, we want more. So if it's something that is of interest for your companies, whether you're end users or provide some sort of services or whatnot, we definitely want more people involved, more companies involved. More people on the technical steering committee. We had very interesting discussions about expanding the technical steering committee. So that's our goal. Community is our greatest asset. So really a call for everyone who's interested. So I hope that I convinced you that it's interesting, that it's open source. And now let's talk about what it is. And actually, OpenSearch is a stack made out of several components. The most important one, or the central one, is obviously the OpenSearch core, which is what was originally Elasticsearch. That's the distributed, search engine. At its core, it's based on Apache Lucene project. We have a Lucene maintainer here, so if you have any questions about Lucene, he's the best guy to answer that. And essentially, a document storage, where you can do the indexing capabilities, of course, and with built-in vector database. We'll touch a bit about that later, but just think about storing documents, think JSONs, and then being able to query based. Obviously, they contain potentially at least some unstructured textual data that you want to query about. It can also be other types of data, geospatial and others. That's the notion. And querying the data based on very simple, intuitive API. That's the core. Then on top of that, there's OpenSearch dashboards. That's like the open source data visualization front end through which you can run queries when you don't run API, when you want to do it in the UI fashion. You can create visualizations, dashboards, visualizing your data. You can also manage your data, manage your indices. You can do some sorts of things about collaboration related. So this is your place, one-stop shop for managing your OpenSearch. And there are additional components. There's the data prepper, a lightweight data collector for the enrichment, transformation, aggregation, all of this pipeline to prepare the data for better better querying afterwards. And there are like client libraries and there are integrations. I'll touch upon them later, but that's in general, that's the stack. And I know Kubernetes folks, so yes, you can also deploy it on Kubernetes. You have your Helm chart, everything's okay if you so choose. So that's the stack. And let's talk about what, and so that's technical, but let's talk about what people use OpenSearch for. So these are the main use cases that we see. First, of course, is OpenSearch. That's search. Sorry, that's where the project originated from. Essentially, enterprise search, highly scalable, performant things that you do for your applications, your e-commerce sites, enterprises, and so on. That's the classic use case. It's also very widely used for log analytics. And expanding into broader observability. So being able to, and again, I know Kubernetes is cloud native, so I'll spend more time about these use cases. Don't worry about that. But we also see growing demand for OpenSearch as a backend for AI ML powered applications with the powerful vector database that is there with integration with AI frameworks like LangChain, like Llama Index, and composing ML workflows. So that's another use case, and also security analytics, detecting, investigating, responding. These are the main use cases. I won't be able to cover all of these in this slot, but I definitely want to cover the first ones, which are very relevant for Kubernetes and cloud native audience. So let's dive right into these. And the first, as I said, search, because this is the origin and the classic, and also it explains the basic set of capabilities that OpenSearch provides. So just like any search engine, matching terms to the objects in your catalog, if you will. Definitely, I like the thinking of e-commerce sites because it helps visualize these things, and matching free text, unstructured data, of course, also structured data. We'll talk about it. Lexical searches, keyword matching based on term frequency and occurrence models, very elaborate models behind it. But the functionality is very intuitive because when you type in a text in your shopping site and you start typing it, and then you see relevant results based on that match. And not only do you see the results, you see them also sorted by how close they are in the match. So you get automatically the relevance or the distance, if you will, of the results from the origin. So that's another thing that you get out of the box. Another element that is mentioned here is faceting. So think about it again like you have the shopping and you want to zoom in to your specific need in a specific material, specific color, specific style or whatnot. You tick the boxes and then immediately the results get narrowed down to your search terms. This is the faceting, the attributes that are relevant for you, supported out of the box. Fuzzy matching, okay? We start typing and we had the typo, some letter changed or dropped or something like that. We still want to see something relevant. So the distance also in terms of the mistyping, if you will. And the vector search, as I mentioned, that's more Gen AI related when the models represent unstructured data as vector embeddings, then you want to check for the vector similarities or the vector distance. Proximity. So that's more on the vector database vector search. And by the way, an excellent talk, I'll mention that further later, but actually combining lexical and vector. There's a talk this Thursday, I'll mention it later, but stick around, and definitely interesting topic of how these actually can come together for more powerful combination. So that's search. And now I want to switch to a demo, because we heard a lot about it, but let's see how it goes. So I want to move into this one, and I want to show you, so we talked about the search, I wanted to show you this one, and as you'd expect, you see this is the dashboard, the OpenSearch dashboards. Again, for those who know Kibana or things like that, it won't be anything out of the ordinary. But for an e-commerce site, being able to see the transactions per day, the breakdown into male, female, average sales price, average sold quantity, you can see the different elements. We can obviously zoom into the specific time frame. The time frame is determined here at the top, okay? So we can zoom in. Obviously, all the dashboard immediately gets updated to the relevant time frame. And then we can see the breakdown inside the graph, the overlay, women's shoes, men's shoes, and so on, very easily visualized. We can see here on a map view, for example, where it comes from and how many and so on. And I think that part is worth having a look. This is essentially the core component, okay? Documents, we talked about document store. So this is the raw data. This is in table format, but this is the raw JSON. And I hope that you can see in the size of the text, but essentially what you'd expect, you see here this is the currency, the customer details, first name, last name, gender, and so on. You can see the order details, date and price, and so on, and the product, lots of details. So all of these are bits of information that you can then query upon, you filter upon, and so on. If we look at the table format, it's very easy, for example, to see. And then you can zoom out. You can say, okay, I want to see only sales that were done on Saturday. Okay, so immediately, if I click here, it's a shortcut for just adding this filter here, day of week, Saturday, and you can immediately see. If I zoom in here, you can see that all the rest of the days disappeared, and we have only Saturday. Okay. So it's very easy to see. And of course, I can add more filters. I can check for, I don't know, city, name. And you see, I don't even need to remember the syntax. It's very easy to just select. And it gives me also the different values available. So I want to see the shopping on Saturday in New York. And then, again, all the dashboard zooms into that specific search. This is the built-in here. They even prepared inside the dashboard filtering by manufacturer, category, quantity, and so on. So that's, in essence, what you get. And this is the e-commerce or the search use case. I want to go back to the slide. Let's see. Just a second. Let's do an extend. So on this one. And let's talk about the other interesting use case, which is observability. Observability. So on the observability front, you can use OpenSearch, of course, to detect, to diagnose, to remedy issues in your system. It could be in your infrastructure, it could be in your application, depending on you. The core that is that most people know, obviously, is around log analytics. We can use the discover pane that you can see. Actually, I should have showed that in the demo as well. But again, for those who are familiar with Kibana and others, it will be intuitive. That's where you can see the raw logs, and you can analyze them as we saw before. You also have, of course, the dashboard's UI that you can build visualizations, visualize your SLO type of dashboard monitoring and so on. And of course, you have other suite of tools like the log tail, log surround, log patterns, and so on. So this is on the log analytics side. and then you can query the data with the most powerful querying is, of course, writing the queries. You can use Lucene for those who are accustomed to Lucene. You have also PPL, query language that was added on top. I'll talk about PPL later. And actually something very nice, you can also have natural language queries that can be converted into PPL, which maybe lowers the barrier to entry for those who are less fluent with these query languages or query languages in general. It also plays very nicely with the cloud native ecosystem. Again, we're here in the cloud local CNCF chapter, so things such as OpenTelemetry, if your system emits OTLP or OpenTelemetry protocol native telemetry, traces, logs, metrics, you can ingest into OpenSearch. You can also, there's support for the trace analytics functionality, and I'll show it in a bit. In OpenSearch Observability plugin now supports the Jaeger data. So if you have instrumentation that's based on Jaeger, you can actually use the OpenSearch's built-in trace analytics capabilities to as a backend for the Jaeger trace data. And you can use OpenSearch to visualize metrics data from Prometheus. So, yes, please.
Yeah, one question, since you said like you have like a standard tracing from Jaeger, you have support for OpenTelemetry. So do you have like native support for like distributed tracing with OTel data? And you can visualize it, or?
Yes. You can send the trace data, the spans, into OpenSearch, and you visualize, and I'll show it in a demo in a second. Yes. So you can use this as the backend for the trace data from Jaeger. Yeah. So really, that it plays nicely with the cloud native ecosystem, which is something that is, again, I'm personally passionate about it, so I'm glad to see, and we'll see soon with the roadmap that this is definitely a direction that is taken also in the next steps. And we talked about it, so let's see a demo for that. I think it's better than just talking about these things, just to see them. So let's have a look here, and let's do the entire screen and go back. So let's start with the log analytics. This is an example of a web traffic that is being monitored, your website. So things that you'd expect, again, monitoring the unique visitors, the breakdown into the different operating systems, whether how many Windows, how many OS X, how many this. You can have a look and see the 404s versus the 200s, the errors. You can also see issues that occurred, like events that happened during this time, so you can correlate, okay, something broke, and then suddenly I have a drop of this and that, so it's very easy to see these markers. You can see in this example, the unique visitors versus average bytes, so each circle like that would show you the unique visitors, and then you can see what is the traffic in bytes in that specific time window. Scatter graph for the different file types like CSS and GZ and the RPMs and so on that were loaded. Heat map, that one is very, very, for those who monitored websites, that's something you usually stick to see where the hotspots in your website, where's the traffic, where it comes from. So the obvious things that you would monitor for your for application. I just mentioned before, so if you look at here, you'll see this is the dashboards, but you can also obviously jump and look at the Discover. This is again, for those who know Kibana, probably this will not be foreign for them. Many people feel comfortable just writing the queries and querying the data in its more raw format. This is the place to go about, and you'll feel very, very comfortable in this area. So that's on the log analytics, and I wanted to show also, and goes back to the question about the trace data and so on. So I think this is a good example, starting actually from top down. So even before the trace data or the spans can actually give you a picture of the relationship between your services in your microservice architecture. So this diagram is automatically generated by the actual traffic, by the actual interaction between the running services in your system. So you can actually, instead of maintaining your own architecture diagram, this is actually what runs in your environment, production or whatever environment you visualize in this monitoring. So, and the nice thing is it overlays also the red metrics, the request rate, error rate, and the duration. So the color scheme, I think, yeah, you can see in the screen the color scheme. You can see in this case it's the duration. You see the ones that are darker are obviously slower. You'll see here, not surprisingly, let me zoom in, the front end of the application. Obviously, the duration, because it's the entry point for your architecture. It's the conjunction point, and so on. You can see the error breakdown, the request rate, and so on. So it's really nice to see that one. And it's, again, automatically constructed based on the trace data. If your application is instrumented to send, of course, trace data. And then you can have a look and see the different services and zoom into them. And going back to the question about the basic traces, you can definitely see relevant traces. You have obviously information about trace groups and so on. I won't delve into that too much, but the nice thing is that if you like investigating performance issues in your application based on the trace data, then this is the classic thing that you'd probably see whether you use Jaeger or other product. You have the same functionality here. Again, we can zoom in to the specific window, and then you can just look at the different spans. You can look at the different patterns, like if you see the staircase, usually something serialized or things like that you can optimize the classic trace play. So you get that together with the observability plugin in OpenSearch. And let's go back here. How am I with the times? Who's giving me the time? Are we good? Great. So that was on the observability side. And now let's say a word about how it looks like from the architectural perspective. I talked about the components before, but I think just laying it out as an architecture, it's a bit easier. So again, you have the data prepper that can ingest, enrich, transform your data collections so they're optimized for the analytics side of the house, and then you store it on the OpenSearch clusters, the log, traces, trace data, metric data, time series, so on. And then you can query it. I talked about before, of course, you can query with Lucene. I talked about the PPL, stands for Pipe Processing Language. Essentially, it's a language optimized for observability use cases to be able to query across logs, metrics, and traces, the different pillars. It's called pipe because you can actually pipe different operations together. You can chain operations, so it's actually piping, even with the pipe that you know from the CLI. So it's nice, and as I said, by the way, you have a nice tool to translate natural queries into PPL. So if you find it difficult to set it up, to compose these at the beginning, and then of course you have the observability UI to manage that. So that's the architecture side of things. And talking about the UI, I want to zoom in a bit about the UI, and that's something that is very important. A lot of the focus of the community, and there are people here to testify for that, has gone into the UI side, the dashboard side, really to an area of the user experience, because we all find the sheer volume of observability data overwhelming. And it's very difficult to navigate, definitely to do the RCA, the root cause analysis, and all that. So getting it a bit more easy to navigate was a theme, an overarching theme that a lot of investment went into that. And you see some examples here. The idea is to allow to manage and visualize your data. That's one focus, to identify and respond quickly, to share insights within and across teams. And it's all need to be accessible, simple to manage, permissions, roles, all of that. So really these are the pillars that drove these sorts of themes. You can see here the anomaly detection as an example of something that is AI driven, helping us to do RCAs and so on. I talked before a bit about the ecosystem. Each one, you come with your observability tool set to a specific ecosystem. Okay, you have in your system a specific sources that emit the telemetry data. You have specific storage solutions that you use. You have your log shippers and whatnot. And obviously, you want the tool to be able to play nicely within the ecosystem that you have. So I think it's very nice to see different data sources that are supported, like FluentBit, again, going into the CNCF stack, FluentD, OpenTelemetry, and so on. You have out-of-the-box support pre-made with Nginx. We talked about Prometheus, Spark, InfluxDB, things that, again, you'd expect to have. Obviously, The ecosystem is expanding, and we're looking forward to more contributions to expand. So if you have something that you feel that is missing and you need the integration, please consider donating it and contributing it to the project. But that's definitely a place to make sure that it's the popular tools for collecting, for managing, for visualizing this information are supported. Another area of emphasis for the community has been around performance, and I think you have someone to testify here better than me. Really, and it's natural, and a lot of users come and use OpenSearch for its ability to manage and explore massive amounts of data. And we all know that performance is always at a premium. The impact on user experience, on time to resolution, like in RCA, in observability, and also in terms of cost. Okay, the amount of storage that it takes. If you reduce it, it's money at the end of the day. We heard about the optimizations also in the previous talk. So you see some examples. This is between the 1.0 and the 2.12. A lot of effort has been done here. You see about indexing throughput, query latency, storage disk space, and others really impressive improvements that have been done. This is 2.12. I can tell you that until the latest, which is 2.19, more improvement has been made. So really a lot of emphasis, and actually pretty cool to see. Just came out last week, or even less than a week ago, on Thursday. Trail of Bits did like a 4-month survey. And performance survey, deep survey around OpenSearch as well as Elasticsearch. They did a very comprehensive study. There's the Big 5 benchmark, for those who know, also vector search and others. So you have the URL. For those who are interested in the performance side, highly recommend to delve into that and look at the data yourselves. They have the raw data shared as well as some of the insights that they have. So interesting to see, and I think very nice results, definitely in some of the elements very, very distinctly for OpenSearch project. So good work for all the maintainers who made that happen. So that's about the performance, and I want to talk a bit about what's new. So for those, I see that some of you are familiar with OpenSearch. I want to give a bit also to about what's new in the recent period. And I mentioned a lot of emphasis has gone into continuing to drive the performance improvements, and also like parallel ingestion processing that you can see here that was released in 2.15, if I'm not mistaken. And also things like the Apache Spark integration that I showed before in the slide, the enhanced anomaly detection, and so on. And also on the UI front, like delivering richer, more user-friendly user experience is still a top priority, and in fact, last year we released version 2.0 of the Discover experience. So for those who know Kibana, I think there's a leap that was made in terms of this experience. For those who love the Discover type of investigation, you'll find some interesting things. And also, we introduced all new workspaces tools to share and manage your observability data across your team. That's also a very nice addition there. So, and again, open source, you have the full project roadmap on the GitHub repo, so feel free to have a look yourselves and see what's relevant for you, and feel free to chime in on relevant issues and things like that that you relate to. So that's about what's new, and I guess the biggest news that is coming actually next month is the next major release, 3.0. So really looking forward to it. I hope that it's still on track for doing it. Okay? Okay, just making sure. So end of April, that's currently the date. Check it out, major release. We follow semantic versioning in OpenSearch. So the breaking changes are kept for the major releases, and this is why we pull the 2.x until pretty extensively. 2.19 just came out last month. But now the community has decided this is the time to make the next major release. There are several interesting things that are coming. One of them is actually upgrading the Apache Lucene version. That's obviously the underlying library and mechanism. So great news about that, but also lots of other things that, as you can see here. Continuous enhancement through performance will carry on. Improvements on the OpenSearch dashboards, more optimizations on the observability applications, improvements to the Jaeger, for those who asked, for example, the Jaeger implementation and more. So stay tuned on that. It's going to be interesting next month. And where can you follow if you do want to follow the 3.0 or generally? These are the places. So obviously, as I said, the GitHub repo is the place. You can find the project there, the roadmap, but you can also find the relevant issues and so on. We also have a very active Slack workspace where all the discussion takes place. So join the Slack. We also have the forums that I mentioned before. There's a blog and lots of events around. So this QR code, if you scan it, you'll have in one page all the relevant links, all of them in one page, so feel free to scan that one. And talking about events, very excitingly, I'll give you a hint. So here, they're very exciting, specifically for the Berliners, we're going to start a new user group here in Berlin, a local community that actually is going to hold the first meetup this Thursday, so 2 days from now, day after tomorrow. It's going to be hosted here in Berlin, very exciting, because you'll have fellows from your own hometown and region that you can exchange ideas with. So scan here or here after the talk. Big thanks, and so to Eliatra folks or your local champions here that are helping set up this user group here, and by the way, in other places around Germany and outside of Germany. So really exciting to see that. We'll have 2 talks there. We have Chris Friedane, my colleague who runs the global communities, community manager of OpenSearch. So he will talk about the community side, how you can get involved, what you can expect, what you can get out of the community, what you can contribute, and how that's one interesting thing. And Eliatra, I mentioned before, Jochen here will talk about combining lexical and vector search. I'm actually excited. I'm sorry that I'm not going to stick around to hear that, but he promised me to fill in on the details. He gave me a teasing that. So actually, it's not either or. You can actually combine it, and that's going to be a fascinating talk. So do check it out. And also, it's a meetup. So essentially, it sounds like some of you raised your hands that you're involved with OpenSearch. Do feel free to reach out to the organizers. It's a meetup page, meetup.com page, so it's open for everyone. And you can see, and you can suggest your own topics. Share your own experience with OpenSearch, whether beginner experience, whether I failed to run this, and everything is good because we can learn from each other. That's the power of community. So do make use of the new user group, and I'm looking forward for the next time that I'm coming to see a big and vibrant user group here. Talking about events, I mentioned that last year OpenSearchCon took place in Berlin. This year it's going to take place in Amsterdam, so a bit farther away from you, but still worth the while, 2-day event, bringing together all the OpenSearch community from all around Europe. And actually, you have folks from outside of Europe that are joining, definitely main maintainers and people who lead the activity, even from the US coming over. So it's really the place that you can get firsthand where things stand, what's the roadmap, how we can get involved, how we can influence. I think that's a great opportunity. So if it's of interest to you, again, also next month, lots of occurrences next month, in addition to KubeCon that was already mentioned. So scan the QR code. Registration is open. Pretty cool. And with that, I'd like to thank you. I'm Dotan Horvitz. This is the QR code, and thank you very much for listening. And happy to take questions if there are any, or if you want to take it in private. Yeah, please.
Can you give me an idea how much OpenSearch nowadays has diverged from the Elasticsearch fork? So especially customer of ours who might run Elasticsearch on-premise and want to migrate into a cloud environment using OpenSearch as a managed service, for example. How much work would it be for a current Elasticsearch user to migrate?
Well, that's a tricky question because it depends. we have several experts. I'll let them also answer, but I'll just give my brief take, and they're more experts than me for sure. But it depends on, if I go as I used to be a solutions architect, I start with questions, okay? It depends which version of Elasticsearch you're running and which version you're going to migrate. You said manage, but anyway, which versions. It also matters which functionality it uses. So my answer would be it depends, and I would ask follow-up questions, but I actually am curious to hear some more opinions here, especially since they do it as system integrators day in and day out. So Jochen, do you want to chime in on this one?
Yeah, I can. So we're pretty familiar with that situation because we're also offering migration services from Elasticsearch to OpenSearch. So let's say if you just quote-unquote use the core features, then it's really basically the same. So the API is the same, format is the same, endpoint is a little bit different. Obviously, so Elasticsearch and OpenSearch. If you use very specific stuff, let's say a very specific feature from anomaly detection, just as an example, it could be that this feature is probably not available in OpenSearch or in some different format. So if you use those use cases or customer uses them, you need to adapt a little bit. But if you're familiar with Elasticsearch, then the migration is really, well, not the migration, but the changes are pretty minimal, I would say.
At least I could expect an Elasticsearch experienced team to adapt still quite quickly and adjust their stuff.
So we had customers that moved from Elasticsearch to OpenSearch. I mean, the actual data migration, that's another thing, right? But from, kind of quote-unquote retraining the team, there was absolutely no effort.
Just wondering, why would you want to do data migration? Also, the basic criteria for a search engine, so for like search in general, is that it can re-index within a few hours. So why would you want to do data migration?
It really depends on, well, that's one path to migrate from Elasticsearch to OpenSearch, doing
re-indexing.
Yeah, but there are also customers that ask the question, what about snapshot restore? Can you snapshot with Elasticsearch and then restore it in OpenSearch? Which is possible depending on the version. It's becoming harder and harder. The higher the versions, the products diverge. But they're different techniques.
I mean, the question is not if it's possible, but if you rely on the accuracy on the search index, like an architectural mistake before, then you should always be able to re-index if you rely on search index.
We're just providing the service. It depends on the customer.
That's a really diplomatic
decisions for the customer. Yeah. But what I can tell you is that what we're seeing is a pattern that customers tend to, let's say they have 10 Elasticsearch clusters, so they're still running, but new projects are started on OpenSearch, and then they phase out the Elasticsearch.
Exactly.
That's
what
the
you
usual.
said. But if you rely on the data on a search cluster, then you made some architectural misconception. Really bad.
Like I said, that's customers.
I want to just to recap, because it's an interesting discussion, but I think the main takeaways for you and for generally is the following. First of all, the projects are diverging. There's no mission statement of OpenSearch to keep full compatibility with Elasticsearch. So if you are planning, obviously the earlier the easier. That's in general, and obviously also in the feature set, the more you use the specialized features of either. Obviously, this will be the points where the migration will be less smooth. And secondly, I think it also depends. We talked a lot about the OpenSearch core, but also on the UI side. So you will need to probably what do I do with all the suite of dashboards that I prepared? Do I import and export and import? Do I do any adjustments? But one thing that I think is important, if you have an experienced Elasticsearch or Elk Stack type team, they will feel comfortable, and that's the main thing. So it diverged. We can talk about the divergence here and there, but in terms of the as you saw, the experience both on the API and the OpenSearch core side, and also on the Kibana/OpenSearch dashboards, you feel familiar. So if your team is comfortable and experienced with the Elk Stack, the migration, or at least in the ramp up, the skill set side, I think you'll find it pretty straightforward. Any other questions? Yeah, go ahead.
More like a blind question. So,
yeah, sure.
Is there anything that, as an advice, that if you want to deploy and scale this application, is there anything that you hear quite often that people do it wrong?
Oh, wow.
In the sense of scaling and deploying.
There's a lot of things that can go wrong, yeah.
You can't do this and you got to
I think there are lots of things that can go. You want to
Like,
talk about what's
like the audience mostly like platform engineer, DevOps is like I care how to deploy and scale.
I know that a lot of people suffer from the same thing, the same problem statement that the Kubernetes people go through, is that is right sizing.
Yeah.
There are various things that sometimes need to be tweaked with certain workloads, and I know that the JVM heap size sometimes need to be tweaked for certain workloads, and that can become difficult.
Okay, so
I'm
it's
certainly not
case
an
to
expert
case.
at that, but yeah, there are use cases where that has to happen, and you know, it is available as a managed service on Amazon as well, and so many of the same difficulties you have to approach as well, like picking the right node size and you know, making sure that you you can even save some money using spot instances as well.
Okay.
And so there's lots of material on that on the AWS blog. If you need to see something that is by the numbers and backed by science rather than anecdote.
Actually, do you want to say, I don't know if people know Nick, he's one of the original people who were involved in actually executing the fork of Elasticsearch, and he's, as I said, he's a Lucene maintainer, and now he has his own startup specializing on on-prem installations. So maybe from your perspective?
Yeah, the biggest one that's almost every single Sev2 issue is shard sizing. Just being able to right size your shards. Most of the time it's too many shards, too many small shards, and then they over-index on too big shards, which can slow down parallelization. So that's probably number one. Number two, like in a Kubernetes deployment, pinning to certain data volumes, because Lucene under the covers is a memory mapped file system, and so you need your page cache needs to be healthy. So that's why the recommendation is 50% of the machine's memory actually goes to JVM. The other 50% of the machine has to be reserved for direct memory. So that's like number two Sev issue is somebody will allocate a 32 gig machine. They'll allocate 30 gigs to the heap, leaving only 2 gigs for page cache, file handle, and many buffers. And then before you know it, your networking locks up and you get too many requests, exceptions, and the whole cluster will go yellow or green, or yellow or red. So, like I said, there's a lot of documentation that we poured into from like Sev2 issues at AWS and all that.
And by the way, lots of them, for those who are, just to complete that, a lot of them is problems that if you are familiar with Elasticsearch, pretty thin, like the sharding and the indices, sizes, and all of that. So for those who are familiar with Elasticsearch, you'll probably experience the same pains. But if you are fluent with these pitfalls, you'll probably know how to avoid them also in OpenSearch. So that's why, because many of the audience know this, I think you'll feel comfortable also in the terms of like the sizing elements and so on. But yeah, these are like very typical. It's been the same pains throughout the years, and still there.
The indexes are hot in page cache. The memory map stays hot in page cache, and so if you don't size it right, you can have thrashing like crazy, just constant paging. That's a big one. That's hard to track sometimes.
I see.
Yeah. Yeah. Please.
Buy big machines. Have fast network. That solves the problem.
Okay. Throw in more bucks.
Have money.
Yeah, throw in more bucks at the problem.
Buy a really big machine.
That's how we get
memory transfer really fast. And have interconnections and don't be cheap. Have 200 gig networks. And more than one line. That solves the problem.
Some problems. Not all of them you can solve with more money, but and also the cost at the end of the month is also something to consider, because well, yeah, it's fair enough.
More experience on cloned machines.
Yeah. Yeah, please.
Yeah, I would be curious. Like I've been like Elasticsearch and Ubuntu user for many years. I feel like when it's about log analysis, like Elasticsearch and Ubuntu has always been like the best player on the market. However, when we talk about distributed tracing, there are a lot of new solutions there. For example, if you think about like Grafana and Grafana Tempo, and I'm just wondering, like, if you think about like this shift from like logs to distributed tracing, doesn't it also require like a rethinking of database architecture and there like comparison how like if you talk about distributed tracing, Elasticsearch or OpenSearch is performing compared to new solutions that are more optimized in distributed tracing, especially if they're like built for especially for telemetry?
So I can't, it's very broad to say compared to, and like it's, I'm not going to do like and I don't think it's my point maybe to do now a point-to-point comparison. I think that there's a lot of investment that has been done in OpenSearch to support what's known the observability plugin or the observability capabilities. And there's a lot of optimization that has been done. By the way, if you think about it, at least on the tracing side, a span is essentially a structured log. Yeah. Okay, so I would say that this is not an alien to the way that data is stored and indexed in OpenSearch or Elasticsearch. Metric data, time series data is a different beast and requires different capabilities. So this is like the newer entrant to the OpenSearch stack. And part of that, by the way, is also the integration, the cross-signal correlation element. For example, being able with a PPL to query across the different signals and not look at it as siloed telemetry signals, but rather as a holistic observability experience. I have a whole different talk about observability as a data analytics problem, and this is exactly looking at it in a holistic. So this is where the project is heading in terms of the roadmap. So again, most of you know it from the log analytics side, but I think it's very interesting, and this is why I wanted to demo it, seeing the more APM capabilities like the service map, being able to see the red metrics, being able to drill down into individual traces and see the spans and so on. So this is the part where we were heading into.
But the thing is, besides of competing from performance side, obviously if you look for a trace metric, you can like easily query it because it's just like a get by key. But then if you focus on that, you have like things that run low key or like logics that work on like object store, which can outperform you very much on cost level.
So again, I'm not going to now do the comparison with a specific project or product. I can tell you that, as I said, a lot of the investment that the community has done and also on the upcoming releases is actually on optimizing for these use cases. So, and by the way, if it's something that you're passionate about, happy to also get you involved and seeing how to do that, because the idea is to get the optimal. As I said, a lot of the investment is into performance, and performance is not just around the query, basic query. It's also about trace related. So the idea is to definitely optimize on that as well.
Like if you want to do the distributed tracing and you want data for one trace, you don't need to query. You just get element by ID, and then the question is like, isn't an object store? As you have it like on local, where you just store an S3 and get data more cost efficient than having it on a database where you have a lot of indexes. Which you need before logs, but if you like distributed tracing, you have like a trace ID, so you don't have this use case anymore. That was just my question.
So it involves several things. If you want to talk about storing on S3 and being able to query directly on S3, this is one feature set that is looked into by the community. There is the optimization of asking by ID, like trace ID or span ID. You can query that. That's actually one of the basic features that you can get also out of the box. So lots of different optimizations here, but I suggest actually taking it offline.
Use case from querying logs to using to distributed tracing, where you go by trace ID.
So I don't think that it's shifting. I see, and I've lived and breathed observability for many years now. I don't think it's a shift. I think it's a mix of different signals. So I don't see the logs being discarded entirely in favor. So your question has a very hidden assumption here that I disagree with. So you're talking about the shift from logs to traces? I don't think that's the right look. I think for microservice-based architectures, for cloud-native architectures, I don't think that logs are going to disappear in the coming 5 or even 10 years. So just to summarize it, so we can debate afterwards. But given that you'll have all the signals, I think the ability to correlate, which is the power of these features like querying across the signals and being able to store them in one tool and visualize in one tool, this is the power that we bring with OpenSearch and OpenSearch dashboards. I think we're about to run out of time, but happy to take more questions afterwards. Thank you very much.
Still beer, still no subscription, so